Okay, so today we're going to be looking at standard formulae in series and sequences, and we're going to be using these three formulas that are given to us on our formula sheet to help us evaluate other expressions. Okay, so what these do is they allow us to work out the summation or the total summation of expressions where n is quite a high number, a high lot of steps, without actually needing to go through them one at a time. Okay, so we'll look at this formula and we'll look at these formulas and show you how to work with this example here. So if I go to example 1, give a bit more space for myself. So example 1, we're going to find an expression for the sum as r begins at 1, r bracket r plus 1 to r plus 3. Okay, giving your answer in fully factorized form. Okay, so that'll be the first part of our question. Okay, we're going to have to find an expression for the sum as r begins to 1 up to n of r bracket r plus 1 bracket 2r plus 3. We want to give it fully factorized form as well. Second part will be hence evaluate (1 times 2 times 5) plus 2 times 3 times 7 plus all the way up to 26 times 27 times 55. Okay, so once we get our answer for the first part, we're going to try and use our answer to find an evaluation of what that list of numbers would add up to if we added them. Okay, so that's our question. So let's start off with trying to find the solution for the first part of the expression. Okay, so the expression they gave me was from r equals 1 up to n of r bracket r plus 1 to r plus 3. Okay, so the only thing I'm going to do is I'm going to multiply these brackets together so I can actually work out what I've got here. Okay, so if I multiply the last two brackets, it's going to be r bracket 2r squared plus 5r plus 3. Oh, let's try that again. That didn't really work that well. Let's try that again. So that gives me the sum n r equals 1. So it's still r multiplied by 2r squared plus 5r plus 3. Okay, so I multiply the last two brackets together, I'm doing that. Then if I multiply everything through by r, I've got the sum, as r goes up to 1 up to n, of 2r cubed plus 5r squared plus 3r. Remember that r there, 3r. Okay, so if you remember the properties from the previous video, we can split up and do the sum of each bit individually. Okay, we don't take the sum of the full thing. Okay, we can split up individually as well. Also, we've seen another property where if it's a constant in front of a term, like in front of the r squared, there's a 5 for example, we can bring that 5 out to the front as well. Okay, so we're going to use the properties from the previous video to do the next step. So if I think out the 2r cubed, the 2 can come out to the front. So I'm going to get n r equals 1 of r cubed there. Okay. Plus, then look at the squared term, it's going to be 5 out to the front, r equals 1 up to n of r squared plus 3 out to the front r equals 1 up to n, the sum of r. Okay, and at this point I can now use my formula that I've got at the top because I know an expression for the sum of r equals 1 up to n of r cubed, r squared and r. I'm going to substitute the formulas into this here, okay? So doing that, okay, so my last formula tells me that the sum of r equals 1 up to n of r cubed becomes n squared bracket n plus 1 squared divided by 4. So I've substituted that in there. Then it's going to be plus 5 lots of what r squared was. So it's going to be n bracket n plus 1 2n plus 1 all over 6 plus 3 lots of n bracket n plus 1 over 2. Okay, so I've just substituted my formulas in there for the r cubed, the r squared and the r. Okay, so that's what we want to try and get an expression of. So we want to try and simplify this and find it fully factorised as the question asked me to do. So the first thing I'm going to do is get the denominators all to be the same. So the denominators can all become over 6. So that would then leave me with 3n squared bracket n plus 1 all squared plus 5n n plus 1 2n plus 1 plus 3n, sorry, not 3n, sorry, 9n 9n n plus 1 all over 6. Okay, so if I combine each fraction algebraically, I've now got that far there. Okay, so what I can do is I can take an n bracket, I can take n out and I can take an n plus 1 out. Okay, because each term's got those there. So if I do that, I'm going to have n bracket n plus 1 out of everything. So my first term I'm going to be left with 3n and n plus 1. Second term I'm going to have 5 lots of 2n plus 1. So I'll take the n and n plus 1 out. And in the last term will just be plus 9. Okay, and again all that is still over 6. Okay, so I'll just do a common factor of n bracket n plus 1 out as well there. Okay, and what that yields to, okay, if I multiply out all the brackets in my second bracket here, so I'm going to have n bracket n plus 1, I'm going to have 3n squared plus 3n plus 10n plus 5 plus 9 all over 6. Just tidying that up. Okay, I'm going to have 3n squared plus 13n plus 14 all over 6. Okay, so I've just combined everything there, took common factor out, and then multiplied out my brackets to find out what I've got left. That there is a trinomial that factorises. So I've got n bracket n plus 1. What this factorises to is n plus 2 3n plus 7 over 6. Okay, so that's fully factorised form for that expression there. I've done the first part of my question there. Okay, so if I now go back to, if I now think about the second part of the question, it said hence find or hence evaluate, and then it asked me to evaluate a sort of list of brackets here. So I'll remind you what that was. So it was asking me to work out what 1 times 2 times 5 plus 2 times 3 times 7. The next one would have been plus 3 times 4 times 9 plus all the way to 25, sorry, it was 26, sorry, times 27 times 55. Okay, so we were asked to evaluate that. Now that was a lot like our question, because what our question was, to start off with, was a sum as r starts of 1 up to n of r bracket r plus 1 to r plus 3. Okay, and what you can see here is this first bracket. Okay, if I make r equals 1, then I've got this first bracket here, don't I? Yeah? Therefore, and if I make r equals 2, I've then got the second bracket there. Those are the same numbers I'd get if I made r equals 2 in those brackets there. And what it's asking me to do is actually sum it all the way up to here, so when r is up to 26 is the maximum. So n here would be 26. That's my last step it wanted me to evaluate. Okay, so r would begin at 1, n would be 26 here. So that would be the sum of 26, r equals 1 of r bracket r plus 1 to r plus 3. Okay, so to the n, the last step would be 26. Now we worked out the evaluation of this when n was just n. Okay, so the evaluation of this was that there. The only difference is I now know that n is 26, so to get the evaluation of this, I'm going to substitute n is 26 into that final answer I got there. So it's going to be 26 times 26 plus 1 times 26 plus 2 multiplied by 3 lots of 26 plus 7, and all that would need to be divided by 6. Okay, and if you do that correctly, so you might want to just tidy this up a bit, so it'd be 26 times 27 times 28 times 85 over 6. And with a calculator you would get the answer 278,460. Okay, so that would be me evaluating that sequence there, because I matched it to my evaluation there, and I worked out that n was 26, which I could sub into my factorised expression for that question. Okay.